Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is meant as a review of applications from your prerequisite algebra class. As such, I don't really go into excruciating detail with examples. If you get lost with the concepts in this video and it's been a while since you took algebra, I highly recommend you watch my full lecture videos on this topic, which can be found in my playlist on YouTube titled Algebra, Lots About Linears. There should be something in there about applications involving systems of equations. I'll still cover kind of the heavy hitters here. We have two examples in this video, and they cover different styles of solutions. So this very first one, you have a Java shop, a coffee place that sells house coffee branded coffee that's only 2.25% caffeine, and they sell that for $6.60 per pound. The house brand is a mixture of Colombian coffee, and that Colombian coffee normally sells for $6 a pound, is 2% caffeine. Then the second part of that mix is a French roast, normally sells for $7.60 a pound, and it has 4% caffeine by volume, I guess they would call it. And then there's a Sumatran coffee that sells for $6.80 per pound and is 1% caffeine. How much of each variety is in a pound of the house brand? So this is, it seems very convoluted, but it's actually not such a terrible problem. When I teach systems of equations and applications of systems in an algebra class, I tend to encourage people to draw pictures. And if you think about somebody who's making a house brand of coffee, which is a mixture of all these, they're really mixing bags of coffees, right? So let's go ahead and just draw some bags in here. And you're adding 3 bags together to become a single bag of the mix, the house brand. So I'll label the mix here the house brand so that we at least know what that is. And what are the 3 varieties we're putting in there? We have a Colombian coffee, a Colombian, a French roast, and a Sumatran. So let me fill that in. All right, so that should visually make sense. Now, we also need to say how much of each of these bags we're adding together. So let's kind of label these bags accordingly. I'm gonna put down here, you don't actually have to label the bag itself, I suppose, but I'll do that anyway. Now, I often think of this as if I walked into a store. Normally at the bottom of a package, they'd say how many pounds of this item there is. And let's make sure that pounds are what we're dealing with. Yeah, notice that in the language of the problem, it says per pound. So I'm going to go ahead and say that we have so many pounds of each of these. And since we don't know how many pounds we're going to put together per, per coffee, that's our unknown. So we're going to let C be the number of pounds of Colombian coffee. So C pounds here. And we'll let, F be the number of pounds of French roast coffee, so F pounds of French roast coffee there, and S be the number of pounds of Sumatran coffee. And in the end, we want to know how much of each, so how many pounds of each, whoops, that was supposed to be a highlighter, but it just did not turn out that way. How many pounds of each is in a pound of the house brand? So I know that the final bag will say 1 pound. Oops, except you have to put pounds in the right order there. Don't know why that didn't work out for me. So 1 pound there. All right, what else do we need to know? So on each bag, they'll probably list the percentage of caffeine that's in that specific coffee. So reading from top down, the Java shop sells a house brand of coffee that's only 2.25% caffeine. So let me put that at the top. This is 2.25% caffeine. Let's see. The house brand is a mixture of Colombian coffee that sells for 6 and it's 2%. So the house brand is 2%. Or sorry, Colombian is 2%. French roast is 4%. And let's see, is that right? French roast is 4%, Sumatran is 1%. So French roast is 4%, and Sumatran is 1%. Now those are things that are kind of listed on a manufacturer's label. And then the price is like a sticker that the shop puts on there. So I'm going to write the price below. So the price of the house brand is $6.60 per pound. So $6.60 per pound. And let's see what else we have. Colombian sells for $6 per pound. I'll write that in there. $6 per pound. And let's see, French roast sells $7.60 a pound. Writing that in there. $7.60 per pound. And finally, Sumatran, $6.80 per pound. So this picture kind of encapsulates everything you would ever need to know about this situation. And you need to form a system of equations out of this. Well, notice that we have 3 variables, C, F, and S. These are the amounts of each coffee that go into the house blend in total. So let's think about at least one equation. We need 1 pound of the house coffee in the end. So that means that C plus F plus S should equal 1. So that's our first equation. That's actually not too bad. That's an equation about the number of pounds. Now we need an equation about the price. Well, the price for this is $6 per pound, and we have C pounds of it. So the price of the Colombian is $6 per pound, and we have C pounds of it. So 6C is how much the cost of the Colombian coffee we have in that mix. And then $7.60 F will be the cost of the French roast. $7.60 times the number of pounds of French roast we have in there. And then $6.80 times the number of pounds of Sumatran. So $6.80 times the number of pounds of Sumatran. And in the end, that should be the amount we charge for a pound of the house, $6.60 per pound. And we only have 1 pound. So I'm just going to put $6.60 times 1 because we have 1 pound. So there we go. We have a second equation involving our variables and all the information given. So again, we have an equation for the weight, I guess, or the amount. And then we have price. And now we'll have one for caffeine, percent of caffeine. All right. And let's see. The Colombian is 2% caffeine. So if you had a full pound of Colombian coffee, 2% of that full pound would be pure caffeine. So we're going to go ahead and say we have 0.02, which is 2%, times the number of pounds of Colombian. That's how much caffeine we get from the Colombian coffee. The French roast coffee is 4%, so 0.04 times the number of pounds of French roast will be the number of the amount of caffeine from that. And then finally, Sumatran is 1% caffeine, so 0.01 times S will be the amount of pure caffeine from the Sumatran. In the end, we want the amount of pure caffeine to be, let's see, 2.25% of our 1 pound mix. So 2.25% is 0.0225. And again, times 1 because we have 1 pound, but that's okay. So note, we now have a 3x3 system of equations. Tackling something like this really is easier done when you draw a picture. It just is much easier to deal with. Now, how do you solve this? Elimination. That's the way I'm going to solve it. And the first thing I'm going to do, honestly, is get rid of decimals. I'm going to multiply each equation by the minimum multiplier so that I get rid of decimals. So for example, in the second equation, I'm going to multiply everything by 10 because that will get rid of all decimals. So this system will then look like C plus F plus S is equal to 1. And then the second equation will be 60, because I'm multiplying everything by 10, C plus 76 F plus, let's see, 68 S is equal to 66. That's just much easier to go ahead and multiply everything by 10 there. The unfortunate piece is this last equation. I would love to multiply by 100 so that I have 2C, 4F, and 1S, but unfortunately 100 would only get me that decimal place there. So I need to really multiply everything by more than 100, maybe by 10,000, which is not fun. I'm going to move the decimal place over 4 units, essentially. So this becomes 2, 0, let's see, 1, 2, and 3. 2, yeah, 200. C, I just moved that decimal place over 1, 2, 3, 4 units. So it became a 200. 200C plus 400F plus 100S is equal to 225. That's really the cleanest way to do this. Then, before I even start solving, so most of, I tell my calculus students the following: when you're doing mathematics, you do arithmetic before you do algebra. You do algebra before you do trigonometry. Before you do trigonometry before you do pre-calculus, and you do pre-calculus before you do calculus. The whole point of that statement is that you don't start your newer mathematics, in this case solving a system, until you're done doing your old mathematics. And if I look at these equations, like the second equation, you could see every term in the second equation is divisible by 2. And in fact, it might even be divisible by 4. Nope, just by 2. So I'm going to divide that second equation by 2 just to reduce the size of numbers. It is often very helpful to do that. So I'm doing that here. Let me zoom out a little bit. So if I do that, I get dividing by 2, 30C plus dividing by 2, that's 35 plus 3, or 38F plus divided by 2, that's 30 plus 4 is 34. Yeah, 34S. And dividing the right hand side by 2, you get 33. And that's as good as you can get on that. That will not clean up any more than that. And the bottom equation actually would clean up quite a bit, because you can divide everything by 5. And in fact, you could divide everything by 25, which will be super duper helpful. Because 25 goes into 200 8 times, 25 goes into 416 times, 25 goes into 100 4 times, and 25 goes into 225 9 times. So that is going to be our equation: 8C plus 16F plus 4S is equal to 9. Not much else you could do there, but it is important. Like, it's good that you see that you do your arithmetic well before you start into systems. Now I can start solving. There's nothing else I can really do here. So when I go to start solving, I think I start looking through at the easiest equations, or the easiest variable to start killing off. And really, I think probably C or S are probably the easiest. I'll just kill off C here. I'll choose to kill off C. So killing off C, let's go ahead and do that. I'm going to take negative 30 times row 1, and I'll add that to row 2 to become a new equation. And then I'll take a negative 8 times row 1 and add that to row 3 to become a brand new equation as well. All right, let's do this. So going through piece by piece, a negative 30 times row 1. Well, I get a negative 30C plus 30C, that's gone. I get a negative 30F plus 38F becomes an 8F. I get a negative 30S plus 34S, that's a 4S. and I get a negative 30 plus 33 is 3. That's not bad. And now let's do the negative 8. So negative 8 times row 1. Negative 8c plus 8c, they're gone. Negative 8f plus 16f is 8f. Negative 8s plus 4s is a negative 4s. Let me write that in there. And negative 8 times 1 is negative 8. Plus 9 is 1. There we go. So those are our two equations. 8f plus 4s is equal to 3, and 8f minus 4s is equal to 1. And you can easily see that you could just quickly add those up. You would get a 16f is equal to 4, or f is equal to 1/4. So we have how much French roast we need, 1/4 pound, and then we can take that value and plug it into either of these equations. I will go ahead and plug it in that top equation. It actually doesn't matter which one, but I'll just plug it in the top. So we get 8 times 1/4 plus 4s is equal to 3. That'll be 2, so we get 4s is equal to 1, or in other words, s is equal to 1/4. Now, I don't really need to go any further than this, because the reality is I know the amount of French roast plus the amount of Sumatran plus the amount of Colombian should be 1 pound. So I know immediately the amount of Colombian is a 1/2 pound, because we have a 1/2 pound between the other two. And so we are done. A 1/2 pound of Colombian coffee, a 1/4 pound of French roast, and a 1/4 pound of the Sumatran. That will give us our ideal blend that we can sell at $6.60 per pound. That will have 2.25% caffeine. And that's how you do this style of problem. The final example is more of a relation example. Meat consumption in the US can be broken into 3 categories: red meat, poultry, and fish. So that's kind of telling us what our variables might be. Let's see, if fish makes up 4% less than 1/4 of poultry consumption, and red meat consumption is 18.2% higher than poultry consumption, what are the percentages of meat consumption? It's kind of a weird setup. So let's walk ourselves through this. The most important piece to note here is where you want to end up. You want to know the percentages of meat consumption. So we're going to define our variables to be that. So here are the variables. Let R equal the percentage of meat consumption that's just red meat. P be the percentage of meat consumption that's just poultry, and F be the percentage of meat consumption that is just fish. And the way they've defined this problem, they've said that meat consumption can be broken into those 3 categories. What this means is that all of these percentages should add up to 100% of the meat consumption within the United States. That is, R plus P plus F should equal 1, which is the same thing as 100%. Let's see if there's any other information we can use. If fish makes up 4% less than 1/4 of poultry consumption. Wow. Okay. So the amount of fish consumption is, that's fish is 4% less. So minus 0.04. So that's 4% less than something. Then 1/4 of poultry consumption. Then 1/4 of poultry consumption. That's what that means. And red meat consumption is 18.2% higher than poultry consumption. So you have poultry consumption plus 0.182 times the amount of poultry. So in other words, you have the regular poultry consumption and it's 18.2% higher than that. Another way you could say that is 1.182p. So it's 118.2% of poultry consumption. There we go. So notice we have 1, 2, 3 equations, and we could totally set this up as a system of equations as written. Now, one thing I should note here is this one is actually already set up kind of nicely. We have R plus P plus F is equal to 1. Okay, that's fine. We have f is equal to 0.25 p minus 0.04. So in other words, f is written in terms of p, but also r is written in terms of p. 182. So if f and r are already written in terms of p, we can substitute those in to this top equation, and we'd have an equation only in p, and we could solve for p. So this one is set up to use substitution. R is 1.182 p plus f, which is 0.25 p minus 0.04, and we want this to be 1. So starting to add things up, let's see, we have 1p plus 1.1, that's 2, plus 0.25 is 2.432. So the coefficient of p is 2.432p is equal to, adding 0.04 to both sides, you get 1.04. Divide both sides by that coefficient, and we get the following. 0.04 divided by that coefficient is approximately, not exactly, but approximately, let me zoom in here, approximately 0.43. That's rounded to 2 decimal places. So basically 43% of meat consumption in the United States is through poultry. Now that we have that, we can go ahead and finish off by finding out, by using these two equations right here. So for example, fish comprises, let's see, roughly around 7%. I just decided to expand the number of digits there just so that we get a more accurate view. And then red meat, again, just taking 1.182 and multiplying it by the amount a percentage for poultry, and we get roughly 0.5055 roughly. So now changing those to percentages, we see that the amount of poultry eaten in the United States comprises 42.76% of our diet, or not of our diet, I shouldn't say it that way, it's of the amount of meat eaten. 42.76% is poultry. Of the meat that's eaten in the US, only 6.69% is fish, and the other 50.55% is going to be red meat. It's like the worst one for you, honestly. And the best one for you, fish, is the lowest. That's super funny. Anyhow, so that is how you would solve a system of equations like that. Every system of equations is slightly different. I was just doing this review video so that you could see, or kind of prime that pump so you could see how to solve systems of equations. Yeah, from the good old days.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.